Welcome back to Low Stress Math with Mrs. Bono. We are on Systems of Equations, Unit 6, Lesson 5, Solving by Elimination, the Independent Practice. Now, if you did not already do the problems on page 28 and 29, stop now and do them. Independent practice means you have to try first. This is just a review in case you missed class. Okay, so let's take a look at the first problem. Elimination means we're going to eliminate one of the variables. So what do I need to do to eliminate a variable? Well, here's my sticky note of things I need to do. 3 things to eliminate. I need the same variable, the same number, and opposite signs. So put my sticky note on the side to remind myself. And I'm going to open this up and say, all right, well, I have the same variables, and here's the same variable. And I have the same number, 2, 2. That's not the same. And I have positive and negative, so that's opposite signs. So I can eliminate the y. So I'm going to rewrite these two, making sure I line things up nice and neat. And I'm going to put a 1 with this x because I don't want it to be by itself. So here we go. 1x plus 2y equals 7. 3x minus 2y equals negative 3. Now I'm going to add those two together. Here we go. 1 plus 3 is 4x. Positive 2 and negative 2 is 0. So that's 0 y's. They're gone now. Eliminated. 7 minus 3 is 4. Divide by 4, divide by 4, and I get x equals 1. That's awesome sauce, except that's not the solution to a system. That's one solution to one variable. So now I have to go back and I have to pick one of the original 2 and put my x in and solve for y. So I'm going to take the top one. X plus 2y equals 7. 1 plus 2y equals 7. Subtract 1 from both sides. I get 2x equals 6. Divide by 2, and x equals 3. La, 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 la. Look at that. Already got my first problem done. So I have x is 1. Oh, look at me. I totally did that wrong. What did I do? I wrote the wrong variable. It's a good thing I looked back and noticed it, huh? I have, this should be 2y. This should be a y. Can't have x and x. 1 minus 1 is 0, but 2y should come down to be 2y. And then when I divide, I get just y equals 3. Whew, glad I stopped myself before I was stupid, huh? So up here I have 1 for x and 3 for y. And I go on to the next problem. All right, same variables in the right spots, good. I have the same number, 1 here and 1 here. Even though they're invisible, they're still there. But I have the same sign. Now, to get the opposite sign, I have to multiply the whole equation by negative 1. That's going to change the sign of every term in this equation. Terms are the individual x's, y's, and 12. Each one of those is a term. So I'm going to multiply negative 1 times each of those terms. But first, I'm going to copy 3x plus y equals 20. And then, negative 1 times x is negative 1x. Negative 1 times y is negative y. Negative 1 times 12 is negative 12. And you forgot your equal sign. There we go. So 3x minus 1x is 2x. Plus y and minus y is 0 y's. 20 minus 12 is 8. Divide by both sides by 2. You get x equals 4. Boom, 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 bam, got it. Now I have to go back and find y. And it doesn't matter which equation I pick, so I'll just take the second one because it's easier. X plus y equals 12. 4 plus y equals 12. Minus 4 from both sides. And y equals 8. Yay, y is 8. So now I have in the golden bar on top, 4 comma 8. And don't forget, you got to put parentheses around it or you're not correct. Yeah, 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 yeah. There we go. The next one. Ooh, look, I got a 0. Okay. Same variables, they're lined up, but I don't have the same number. I have 5 here and 2 here. Ugh, that's a mess. How about this? I have a 2 here and I have nothing there. Well, if I made that -2, see, there's an invisible 1 here. And if I multiply this whole expression by -2, then I can subtract and it'll be, the x will disappear. So let's take that top one and rewrite it. X plus 5y equals -1. Now I'm going to multiply -2 times everything. -2 times 1x is -2x. -2 times, that's a positive. Negative times positive is -4y. -2 times 0 is just 0. Now when I combine them, look. 2 minus 2, the x disappears. It's eliminated. 5 minus 4 is 1y. And -1 minus, plus 0 minus 0, whatever, it's just -1. If I put a box around it, it's beautiful. Oh, but I'm not done. So I'm going to go back and I'm going to take the second equation, the one I changed, do x plus 2y equals 0. And where the y is, right there, that's where I'm going to put the -1. So x plus 2 times -1 equals 0. 2 times -1 is -2, so x minus 2 equals 0. I skipped a step, it's okay. Positive, negative, negative. Add 2 to both sides. X equals 2. Boo, boo, boo. Y is -1, x is 2. Now be careful. X goes first. It's 2, comma, -1. Don't fall into that trap. And there you go. 2, comma, -1. Thank goodness. Look, the x's are lined up, the y's are lined up, and I have a +5 and a -5, and I am a gold because I don't have to multiply by anything. 3x plus 5y equals 10, and then this is 1x minus 5y equals -10. I can just add those together. 3x and 1x is 4x. 5y minus 5y is 0. Wait a second, 10 minus 10, that's 0 also. Divide by 4, divide by 4, you get x equals 0. That can happen sometimes, you gotta be careful. So now I'm gonna put that back up into one of the equations. So I'll put it in the first one. 3x plus 5y equals 10. 3 times 0 plus 5y equals 10. 0 plus 5y is 10. Well, what's 0 plus 5y? That's just 5y. That equals 10. Divide by 5. And now I know y equals 2. 0, comma 2. Up in the gold goes 0, comma 2. All right, not too bad on that page. Let's take a look at the next page. Don't get mad at me if one of these happens to have a fraction in it, because sometimes fractions happen. It's all right. You don't mind, right? One little tiny baby fraction? It's all right. It happens. Here we go. All right. Okay, that is a great problem. Look at that. I know I have the same variables lined up. That's good. And the -6's are also lined up. But I can eliminate the x if I multiply times -1. So let's multiply this one times -1. So I'll keep the top equation. negative 6x minus 4y equals 21. And I'll multiply times negative 1 on the second one. Negative times negative is positive 6x. Negative times positive, negative 3y. And anything times 0 is 0. Okay. Negative and positive, that becomes 0. Negative 4y minus 3y is negative 7y equals 21 plus 0, 21. Divide by negative 7, and y equals negative 3. Well, that's a sloppy mess. Oh, I know. Shh, it's okay. So we got that. Now I got to go back and fill that in one of the equations to find the x. Let's take the bottom one because it's all positive. Negative 6x plus 3y equals 0. Negative 6x plus 3 times negative 3 equals 0. 3 times negative 3, well, that's negative 6. So negative 6x minus, wait, 3 times 3 is 9, Bono. Minus 9 equals 0. Add 9 to both sides. This is going to be a fraction. Don't be mad at me. Negative 6x equals 9. Divide by negative 6. And you get, sadly, x equals negative 3 over 2. Now, if you did it with me in class, you know I used the second equation instead of the first equation. I mean, the first equation instead of the second one. And I got the same crazy answer, negative 3 over 2. It's okay. Sometimes fractions happen, but I know it's correct. I've double checked. So, negative 3 over 2, comma, negative 3. Those are our answers. Got to live with them. The next one, let's see. Well, the x's are lined up, the y's are lined up, and no. But you know what? If I change this one and multiply times 2, then I will have, hopefully, the same number in an opposite sign. So keep 3x plus 6y equals 6. 2 times 2 is 4x. 2 times minus 3 is minus 6y. This should be a y. Equals 2 times 4 is 8. All right. Combine like terms. 3 plus 4 is 7x. Negative 6y and positive 6y is 0. And 6 plus 8 is 14. Divide by 7. And x equals 2. I'm so glad that's not another fraction. Ugh, fractions. Okay. And let's take the top one. 3x plus 6y equals 6. 3 times 2 plus 6y equals 6. 6 plus 6y equals 6. Subtract 6 from both sides. Oh gosh, we're going to get another 0. Too many zeros, Bono. 6y equals 0. Divide by 6, and y equals 0. So I have x equals 2, y equals 0. And that is too big, squishy. So 2 comma 0. All right, and now the last problem on this page you could not do because Bono forgot to give you the problems. But don't worry, I got some problems we can grab. Let's do y equals 2x plus 3, and y plus 3x equals 6. Let's graph those. First, y equals mx plus b, which works just fine on this first problem, but not so good on the second one. So we're going to begin at the back at the b. b equals 3. So here, 1, 2, 3. And then to get more points, I use the m. m equals 2 over 1. So I'm going to rise 2 and run 1. So from 3, was it positive 3? Yeah. From 3, I'm going to rise 2 run 1, rise 2, run 1, and then I go down 2 over 1, and that's pretty good. Why do I think I did that wrong? Because you did, Bono. You copied the problem wrong. I'm looking at my paper right now, and look at that. It says -3. I was supposed to start at -3 and go up and over from there. I'll make myself a nice parallel line here. Silly Bono. Make sure when you graph your line, you go above the grid and below the grid. And grab a whiteout. And next time, graph in pencil, Bono, because if you graph in pencil, when you make a mistake, you just have to erase it. But now you have to have whiteout all over the paper here. So this was supposed to be 2x minus 3. I can't believe I did that. Here we go. And now we can graph that. Oh, no, you can't. It's not in the right order. Oh, darned. I have to subtract 3x from both sides. But look, don't line them up because they're unlike terms. This is 0. Y equals -3x plus 6. I'm going to start at 6, and I'm going to go down 3, 1 to the right. Down 3, 1 to the... What did I do here? Ugh, they're not going to even cross in a nice spot? Oh, well. That's a hot mess of a problem you got there, Bono. And maybe they just don't have a nice answer. Here we go. Y equals, no. Y plus 3x equals 6. And y equals 2x minus 3. They have an answer, but it's in the middle of the box, so we're not going to use that. Okay, take care. Talk to you later.